Now let us understand about eddy currents. Now we have already studied that if we have a rod in a magnetic field, and if we change the orientation of the rod, if we rotate the rod or if we move the rod in some direction with velocity v, and there is some magnetic field around it, then the magnetic field lines will be cut by these rods, by this rod or the wire, and there will be EMF induced. Similarly, if there is a rectangular coil and it is moving in the magnetic field, or the magnetic field linked with this coil is changing, then again there will be an induced EMF, and hence there will be induced current in both of them. But instead of a wire or a rod, if we have a solid metal piece, now this is a solid metal piece like this, and it is kept inside a magnetic field which is directed perpendicularly outward. Now if the piece is just lying there, then there will be no induced EMF. But if we are either changing the magnetic field or if we are moving the piece so that it cuts the magnetic field line, then there will be current. Now the difference between the metal piece, solid metal piece, and a rectangular coil will be that the current in rectangular coil might have this path or anti-clockwise. So it will, since it is a coil, it will go around this path only. It is the only path available for this current. But in a metal piece, when it cuts the magnetic field line and EMF is induced, then the induced current will have the entire body of the metal piece to move around. So in such cases, what happens is that the current, it moves in circles like this. The entire body has induced current and it moves in circles. Now because this current moves in circles, that is why it is called eddy current. Now eddy, it is also called Foucault current, because after the name of the scientist, and eddy is the name of whirlpool. It is another name for whirlpool. If you have seen that, suppose in a wash basin, if the wash basin is filled with water and suddenly the outlet is open, the water will move in circle while going down in the wash basin. Now this circular motion is called whirlpool, or it is called eddy. Now this revolving current, this circulating current is same as this. That is why the name eddy current has been taken. Now when this induced EMF is moving in circles and produce eddy current, then this eddy current also follows Lenz's law. That means it is going to resist any reason because of which it is produced. So let us say that if this eddy current is produced by changing magnetic field, then the induced EMF or induced current or the eddy current in the metal piece will be such that it will go against the change of the magnetic field. Or let us say that if this metal piece is moved in this direction, then the EMF, the current will be produced in such a way that the magnetic field produced by this current will try to move the metal piece in the opposite direction as it is given by the Lenz's law. Now because of this and because of the induced current, there is heat generated because of this current, because obviously the metal piece will have some resistance, so some heat will be generated given as I square RT, and because of this heat, the application of eddy current generally involves uses of heat. So the most basic use of the eddy current is induction furnace. Now in induction furnace, a metal ore from which we extract pure metal, that ore is moved inside a high strength varying magnetic field. Now when that happens, the eddy current is generated, and because of that, large amount of heat is generated and this ore is melted and the pure metal can be refined. Similarly, there is another application for this eddy current which is not related with heat, and that is called deadbeat galvanometer. Now in a galvanometer, whenever it detects current, there is a needle like this, there is 0 in the between, and there are certain divisions plus this side and minus this side depending upon the current, the direction of current. Now whenever a galvanometer detects a current, this needle moves to a particular value, but it does not come to the rest at once. So the reading of value becomes difficult because the observer has to wait for the needle to come at rest. So the needle will keep on oscillating for a certain period of time. Now because of eddy current, we can, the deadbeat galvanometer is made, because of which if the needle gets deflected, then it does not oscillate much and it comes to a rest very quickly, so that the reading of the values become very easy. This is because of the eddy current, because the eddy current, whenever the needle moves, the eddy current is generated in such a way that it opposes the motion of the needle. So when the needle tries to oscillate, the eddy current is generated in the reverse direction, and that brings the needle to the rest very quickly. So these are two main uses of eddy current which will be useful for your exams also. Generally in questions it is asked to write the two uses of eddy current after defining them. So we can, in my notes I have given the details of both of these application, induction furnace and deadbeat galvanometer.